See, this is the 2025 advanced question paper 1, right? So, let R denote the set of all real numbers A, B belongs to 5, 1, 2, 3. Define the function fx gx like this, right? Fx not equal to gx for every x belongs to R. Then the coefficient of x cube in h of x is. So, this is the question, right? So, here h of x is f of x plus 1 minus g of x plus 2. So, therefore, h of x is f of x plus 1 minus g of x plus 2, right. So, h of x is equal to f of x plus 1. So, in this wherever x you write x plus 1. So, therefore, what you can write a1 plus 10 into x plus 1 plus a2 into x plus 1 whole square plus a3 into x plus 1 whole cube and x plus 1 power 4. Now, minus g of x plus 2, wherever x you write x plus 2 in gx. So, minus of bracket b1 plus 3 times x plus 2 and b2 into x plus 2 whole square, b3 into x plus 2 whole cube, x plus 2 whole power 4. So, that is 3 into x plus 2 plus b2 into x plus 2 whole square plus b3 into x plus 2 whole cube plus x plus 2 whole power 4. Yes, this is the what h of x, right. So, in this we want coefficient of x cube we want, right. Therefore, coefficient of x cube is equal to, see here you will get coefficient of x cube a3 into x cube, a3 into x cube. So, that is a3. Then next here we will get this b3, right. Here also x cube is there, x plus 1 power 4, x power 4, 4c0 x power 4, 4c1, that is what, plus 4, right, minus in this x cube coefficient here b3 x cube. So, b3 and here 4c1 x power 4 into 2, 4c1, right, 4c1 into 2 x cube coefficient. So, therefore, coefficient of x cube is equal to a3 plus 4 minus b3 minus 4 to the 8. So, a3 minus b3 minus 8. 8 minus 8 plus 4 is minus 4. What is that? Minus 4, right, 1. But what is given? Fx not equal to gx given. Fx not equal to gx. So, fx not equal to gx given. So, therefore, right, but fx not equal to gx, right, that means fx minus gx not equal to 0. This means what? Fx minus gx equal to 0 have no real roots. Therefore, fx minus gx equal to 0 have no real roots. So, what is but fx minus gx? Fx minus gx is, you can write this, subtract a1 minus b1 7 and this a1 minus b1, right, a1 minus b1 plus 7x and what is the square term? a2 minus b2 x square, a2 minus b2 x square plus a3 minus b3 x cube. Then that is x power 4 cancel, right? So therefore this have no real roots, no real roots. That means what? X cube coefficient must be 0, right? So therefore a3 minus b3 0, right? So put in 1, you will get what? Coefficient of x cube is 0 minus 4 minus 4. So therefore coefficient of x cube is equal to 0 minus 4, that is what? Minus 4. So that is what option, right? C. Now, so here the 3 students S1, S2, S3 are given a problem to solve. Consider the following cases. U, at least one of students solve the problem. V is S1 can solve the problem given that neither S2 nor S3 solve the problem. W, S2 can solve the problem. S3 cannot solve the problem. T, S3 can solve the problem. For any event E, P of denotes the probability of E. P of U of this. So then is asking P of T. P of T is asking, right? Okay. So for this you can take, right? You take, suppose let, right? You can take this, let P of S1 is A, P of S2 is B, P of S3 is C. So these are what? Independent events, right? Or independent events, or independent events, or independent events. So what is given? And U is U. What is that? U is problem will solved. That is either S1 solved or S2 solved, S3 solved. So what is U bar? None of the students will solve. S1 not solved, and S2 is not solved, and S3 is not solved. This is what P of, this is what U bar. Now we want P of U. So that is what P of U is, what is that? 1 by 2, right? P of U 1 by 2 means problem will be solved. So this is also nothing but, so 1 minus none of the student will solve the problem. So that is, you can take 1 minus probability of none of the student will solve the problem is equal to 1 by 2, right? So what is this now? 1 minus half, right, is equal to, this is P of S1 bar, and independent, no? S1 bar, S2 bar, S3 bar also independent. So P of S2 bar, P of S3 bar, right? But P of S1 is what? A. P of S1 1 minus A. So therefore, can take this as, right, 1 minus A, 1 minus A, 1 minus A into 1 minus B into 1 minus C is equal to 1 by 2, equation 1, right? P of S1 bar, P of S2 bar, P of S3 bar, right? Now P of V is 1 by 10. V is what? S1 solve the problem given that neither S2 nor S3 can solve. So P of V is 1 by 10. P of V is 1 by 10. So what is that? Probability of, given that this neither S2 nor this, given S1 can be solve the problem. So P of S1 by S2, neither S2 nor S3 can solve the problem, right? Conditional probability. So it is nothing but what? P of S1 intersection S2 bar intersection S3 bar by P of S2 bar intersection S3 bar is 1 by 10. So this is nothing but P of S1. So, therefore, P of S1 is equal to 1 by 10. Therefore, A is 1 by 10. A is 1 by 10. So, equation number 2. Now, P of W is 1 by 12. P of W is 1 by 12. So, P of W is 1 by 12. So, P of W is what? P of W, S2 can solve the problem, S3 cannot solve the problem. So, S2 solve. So, probability of S2 is solved and S3 cannot solve, right? S3, so bar is equal to 1 by 12. Again here, P of S2 into P of S3 bar is equal to 1 by 12. But P of S2, what is that? B. P of S3 bar 1 minus C, right? So, therefore, you can take this as, right? So, we can take, goes this side. So, what is this? This is P of S2 B and 1 minus C 1 by 12, equation number 3. Yes, now we will solve for A, B, C. But he is asking what? Asking them P of T. P of T means S3 can solve. So, P of the S3, that is what P of S3 means that C. We want C, right. So, here 3 equations, right, 3 equations. We can solve these 3 equations, 3 unknowns, right. You put 2 in 1, right. Put A is equal to 1 by 10 in 1. So, that is what? 1 minus 1 by 10 into 1 minus B, 1 minus C is equal to 1 by 2, 1 by 2. So, this is what? 9 by 10, 1 minus B into 1 minus C is equal to 1 by 2. 2 5s are cancel. So, that is 1 minus B to 1 minus C is 5 by 9. Equation number 4, right. Now, we will divide 3 and 4, 3 and 4. So, therefore, 4 by 3 you can write, 4 by 3 I am writing, 4 divided by 3, that is 1 minus B into 1 minus C by B times 1 minus C is equal to, what is that? This 4 is 5 by 9 and this 1 by 12, 12 by 1 reciprocal, right. So, 1 minus C cut, 3 3s, 3 4s, right. So, you will get 1 by B minus 1, divide 1 by B minus B by B 1 is equal to 20 by 3. So, from this 1 by B is 23 by 3. So, B is equal to 3 by 23, okay. But we want actually what? C. Put in 3, right. Put in 3, you will get, right. So, 3 by 23, 1 minus C is equal to 1 by 12, From this C you had to find. C value, that is P of T. What is that? 1 minus C is 23 by 24, right. So, 1 minus 23 by 24 is C. So, this is what? 13, 24 minus 23 minus 24, right, 3 by 23, 20 by 3, right, but what is that? Okay, somewhere, right, this is what? 1 by 10, A 1 minus 1 by 12, and put this equation in this 1 by 2, this is 2 5s, now see 5 by 9, divide this by this, 1 minus B, 1 minus C by B by 1 minus C, 5 by 9, 1 by 12, 3 3s, 3 4s, that is 20 by 3. 1 by b minus 1. So, plus, right, plus 23 by 3. B is 3 by 23 and put here, oh, 3 by 23 this is, not 2 by 23. So, 3 by 23, right, that is 23 by 36. So, this is 23 by 36. So, 23 by 36, right. So, we have this is what 36 minus 23, 13 by 36, that is a P of t. Yes. So, that is nothing but P of S3. So, answer is 13 by 36. 13 by 36. So, therefore, option A. So, this is right. So, fx equal to 2 minus 2x square minus x not equal to 0, 2 when x is 0, right. Then which one of the following statement is true, right. Okay, we will find out this. What function is not differentiable? There is a positive real number delta such that this, and for any positive real number delta, the function f is not an increasing function on the interval minus delta 0, x equal to 0 is a point of local minima of f. Okay. So, for this, first we will find out, right, this left differentiate light derivative will calculate, find the LH D RH D, right. So, first we will find out A, whether it is differentiable or not, we will check, right. So, at 0, so f dash 0 plus, matlab right derivative, right. So, limit h tends to 0, f of 0 plus h minus f of 0 by h. This is a f dash 0 plus formula at 0. F of h. So, wherever x you write what h in this, not second, right. So, that is what limit h tends to 0 2 minus 2h square minus h square sin 1 by h, f of 0 is what 2 whole by h, 2 to cut, h cancel. So, this tends to 0, right, h cancel, minus 2h minus h sin 1 by h, okay. So, therefore, this tends to 0 because h tends to 0, this 0, this 0, so tends to 0. So, right derivative is 0. Now, we will find out the left derivative, right. So, f dash 0 minus, so limit h tends to 0, right, f of 0 minus h minus f of 0 by minus h. This is a left derivative. So, therefore, f dash 0 minus is limit h tends to 0, f of 0 minus h, 2 minus 2h square, 2 minus 2h square, and here minus plus h square, because minus h square, this is plus h square, but minus 1 by h minus, sin minus theta minus plus. So, plus h square into sin 1 by h and again minus 2 by minus h. This also tends to 0. Again minus h cancel, right. So, limit h tends to 0, here minus h common. So, this is 2h minus h, right, sin 1 by h whole by minus h. So, minus h cancel. So, this is also 0. So, differentiable. So, this is not correct, right, this is not correct. Now, there is a positive real number delta such that f is a decreasing function on the interval 0 delta. right, on the interval 0 comma delta, it is increasing. So f is decreasing function, right. So it is obviously continuous, right. So we will find out, that is what B, f dash x we will find out, f dash x. What is that? Minus 4x minus x square into cos 1 by x into minus 1 by x square, and minus 2x into sin 1 by x, right. So what is this? So f dash x is minus 4x, here minus plus cos 1 by x minus 2x sin 1 by x. Okay. See, this actually sin cos 1 by x, sin 1 by x oscillates between minus 1 plus 1. So we cannot say that it is increasing, decreasing in the neighborhood of 0, right. So as cos 1 by x comma sin 1 by x belongs to minus 1 to 1. So therefore fx is right, neither increasing nor decreasing. So it is oscillates, right, is neither increasing nor decreasing. That means it is something like that at 0, here it is like infinity to minus infinity to like this, plus infinity like this. So it is something like this. Okay, of course here it is infinity. Okay, so here it is no, neither increasing nor decreasing. So therefore it is B is also not correct. Is also not correct. Now, for any real number, the function f is not an increasing function on the interval minus delta 0. Yes, minus delta 0. So here minus delta 0. In this also we cannot, here small oscillations are there. So therefore, yes, this is correct. For any positive real number delta, function f is not increasing. No, here it is what oscillations are there? Small oscillations are there. So therefore, this is correct. And obviously, only single answer C only. So now this is the question matrices, right? Okay. So here what is that? Question is P given. What is the P nature? Diagonal matrix. Consider the matrix, right? Let the transpose of matrix X denotes X transpose. This 3 by 3 invertible matrix Q with integer entries such that this PQ is. So number of 3 by 3 matrices. So we want number of 3 by 3 matrices we want. Okay, invertible. Now determinant not 0. Okay, now we can take here P is given, no? Let Q you take, right? Let here I will write. Let Q is a matrix like this 3 by 3 because PQ must be exist product is also 3 by 3 given 3 by 3. Okay, A B C D E F G H I. You can take this and given PQ is equal to QP, right? So PQ is equal to QP, right? PQ is equal to QP, right? So P is this diagonal matrix. So 2 0 0 0 2 0 0 0 3 and Q is this matrix A B C D E F G H I is equal to Q is A B C D E F G H I and the diagonal matrix 2 0 0 0 2 0 0 0 3, right? Okay. Now we can multiply this matrix and equate. Some values will get, and other condition will get this, right? So what is that? 2a, this is what? 2a, right? 2a, this first row, first column 2a, 2b, then next 2b, next 2c, yes, 2c, right? Next this is 0, this 2d, you know, 2d, then next 0 0 2e, 2e, 0 2f, 2f, then 0 0, this is what? G, H, this 3g, right? 3g, this is 3 0 0 3i, you know, this row 3 0 0 3i. This is first row, first column. Sorry, this is not correct. This is for third row, first column. This is what? This is 0 3h, 3h and 3i. Okay, is equal to, now this is 2a, 2a, next this 2b, then next this 3c, next 2d, right? This 2d, then 2e, next 3f, next this is 2g, and this 2h and 3i. Okay, right? Now you compare the coefficients. 3c equal to c0, right? c0, f0, right? And I0. Okay, so somewhere so this is okay, this is okay, G0, here it is the case, this is 0 0 3f I0, cannot be I0, that is right? So 2a, this is what? This only one element, this element is 3g, this 0 0 3h and 3i. Okay, so I cannot 0, right? Because 3i equal to 3i, na? Right? So c0, f0 and g0. Okay, now we can put this here. So therefore Q matrix can be is this: A, B, 0, D, E, F0, right? G0, H, yes, H also 0, because 3H is 2H, H0, right? And I is I only. This is the Q matrix, and one more condition is there. Now we have to find out A, B, C, D, E, I values, right? So, okay. So therefore, what is the another condition? Q inverse is QT, right? Q inverse is Q transpose, right? So, multiply both sides by Q. Q into Q inverse is Q transpose. This is I. Matlab it is a orthogonal matrix. It is a orthogonal matrix. Q into Q transpose is I. Okay. Now, this is a Q matrix, right? So, what is that? Q A, B 0 and D, E 0, 0, 0, I. Now, transpose I am writing A, D 0, B, E 0, 0, 0, 1, 0, 0, I. Yes, is equal to, what is that? 1, 0, 0, 0, 1, 0, 0, 0, 1. I, right? I wrote here is equal to I. Now, compare this. A square plus B square is 1. A square plus B square is 1. AD plus BE is 0. This AD plus BE is equal to 0. AD plus B 0. Then next D square plus E square is 1. D square plus E square 1. Yes, we have to find out A, B, D, E, I. I anyhow that is what? I is equal to 1 that is I square. Right? Here I square is 1 again. I into I square is 1. So, I square is 1. You know this. I square is equal to 1. Right. Now, here if you take this, suppose AB values, okay. So, if you take this is 0, 1, right, and 0 minus 1, and DE values you can take DE. What is that? That is 0, 1, 1, 0 and minus 1, 0, minus 1, 0. Now, case 2, what is that? AB, interchange 1, 0, minus 1, 0 and DE is 0, 1, 0, 1 and 0 minus 1, minus 1, 0 minus 1 this. Here this is minus 1. Okay, we can write 0, comma minus 1. Yes. So, I square is 1. That means what? Each case is what? 2 values. 2, 2, 2, 4, 16. Right. So, therefore, right, number of matrices of Q are 16, right, 16 cases possible. So, that is what, so C is correct. Now, this is a question from 3D. Let L1 be the line of intersection of planes given by the equations, right. Let L2 be the line through this point parallel to L1. Let M be the plane. Let M be the plane, right. Another plane is this equation. Now, suppose that L2 meets the plane M at the point Q. Let R be the foot of perpendicular drawn from P to the plane M. Then, which of the following is are true? Oh, this is a more than one type questions. Okay. So, we can write. So, these are the two planes intersect. There is a line. Okay. So, that is what can take. Right. So, two planes intersect. There is a line. So, this is the figure. This is the one plane and this is another plane like this. This is L1. This line is L1, right? This plane is what? This is the P1 plane, 2x plus, right, 3y plus z is equal to 4. This is the P2 plane, x plus 2y plus z is equal to 5. Yes, this is the what two planes intersect, there is a line formed. That line is L1. Now, L2 is a line passing through this 2 minus 1 and parallel to this. Okay. So, this is some other line, okay, here passing through this and right. So, I can take like this. This is the P point. P is 2 minus 1 3. P 2 minus 1 3 passing to this parallel to this L1, right? L1, and let M given by equation this plane. Suppose the line L2 meets the plane M at Q. Okay, this is the plane M. This is the M plane. This, right, it is at Q. This is Q. Okay, something like that. So, therefore, what, let R be the foot of perpendicular drawn from P to the plane M. Okay. So, this is the foot of perpendicular from P to this, something like that. This is the foot R. Yes, this is the figure. Okay. Now, we can find drs of this. We can find the drs of this line, L1 line. So, that same as drs of PQ, right? What is this M plane? M plane is 2x plus y minus 2z is equal to 6, right? Okay. So, now drs of L1 same as drs of L2. This is L2 line. This is a L2 line. Okay. So, let Lmn be the DCs of this. Let Lmn be the DCs of L1. So, therefore, here it is perpendicular to this normals, this line. So, 2L plus 3M plus n is equal to 0. Now, this line is also perpendicular to this normal. Again, L plus 2m plus n is equal to 0. Yes. So, by it is nothing but A cross B. It is nothing but A cross B. That is IJK 2 3 1 1 2 1 like that. This I am doing like this. So, therefore, you can take here 3 2 method of cross multiplication, 3 2 first starting middle, then 1 1, then 1 1, 2 1, 2 1 and 3 2. So, this is what Lmn. So, L by 3 minus 2 1, M by 1 minus 2 minus 1, N by 1. Now, these are the drs, denominators. The proportional values of DCs are drs. So, now these drs same. So, you know point, you know drs and point line L2 we can find. So, therefore, L2 is x minus 2 by A 1 and y plus 1 by minus 1 is equal to z minus 3 by 1. Z minus 3 by 1. Okay. So, now we can, this line meets M at Q, then we want a, what is that? PQ length, right? Okay. Now, we will find out the any point on this line, So, you can take a T say, therefore, any point on L2, that point you can take a Q, that is what? T plus 2 minus T minus 1, T plus 3. But this point lies on the plane M. Substitute. We will get T value, substitute back Q point, PQ distance. Okay. So, therefore, put in the plane M. So, what is that M plane? This is the M plane. 2x plus y in the plane M, that is 2x plus y minus 2z is equal to 6. Okay, substitute this 2t plus 4 minus t minus 1 minus 2t minus 6 is equal to 6. 2t cut. This is what t is equal to, right? 12 minus 12 minus 13, so minus 9. T is equal to minus 9. Put in Q, right? So, what you will get? Q point is minus 7, that is what? 8, then minus 6. This is the Q point. Now, PQ distance, right? PQ distance. So, therefore, PQ square root of. So, P is what? 2 minus 3 minus 2 minus 1 3. 2 minus 1 3. 2 minus 1 3 is 81. Add minus 1 minus again 81. Again 3 plus 6 9 81. Yes. So, 9 root 3. Yes. Yes. A correct. 9 root 3. Now, so this length QR. Let us find out the foot of perpendicular. This R is foot of perpendicular from P to plane M. So, therefore, we can find foot of perpendicular, that is from the point to this plane M, foot of perpendicular. Okay. So, so that is foot of perpendicular from P to on the plane M, is R. Okay. You know foot of perpendicular formula, that is alpha minus 2ak, beta minus 2bk, gamma minus 2ck, right? Right. So, what is that alpha? Alpha is 2 from this point. This is alpha, beta, gamma. 2 minus alpha, 2 minus alpha minus ak. A is what? 2. 2, right? Substitute this point in the plane. That is what? 4 minus 1 minus 1 minus 6 by a square b square c square. 4 1 1 9. Okay. Now, minus 1 right, minus 1. Now alpha, b is what? 1. This k is same this. 13 minus 4 9 minus 1 and 3 minus plus 2 into minus 1. Yes. So, R is 2 plus 2 4 0 0 1 4 0 1. This is a foot, right? That is R point. Okay. So, now we have to find out length QR. So, Q is this, R is this. Therefore, QR is equal to root of this 121 and 64 and 49. What is this? Root of 50. Sorry, this is 130, 170. 170 plus 64, that is 234. It is not equal to 15, right? I think this is not correct, right? Now, area of triangle PQR. Area of triangle PQR. You know, P point, Q point, R point. Well, this area, right? So, area of the triangle PQR, this area is asking. So, you know, area of triangle ABC in 3D, what is the half, right? AB bar cross AC bar modulus, right? Vector concept only. So, therefore, PQ cross PR bar will write. So, therefore, area of triangle PQR. So, therefore, area of triangle PQR is 1 by 2 modulus PQ bar cross PR bar. Okay. Yes, this. Of course, modulus also 1 by 2, right? Modulus IJK, right? PQ, OQ minus OP, minus 9, 8 plus 1, 9, and minus 6, minus 3, minus 9. Yes. Next, PR bar, OR minus OP. This is R, OR minus OP. 4 minus 2, 2. 4 minus 2, 2. 0 plus 1, 1. And 1 minus 3, minus 2. Minus 2. Okay. Now you can take 9 common. So 9 by 2, right? IJK minus 1, 1 minus 1, 2, 1 minus 2. No. So 9 by 2 into root of minus 2 plus 1 is 1 plus J coefficient square. 2 plus 2, you know, 2 to 4, 16. 16. K coefficient minus 1, so 16 again, right? So, I into minus 2 plus 1. Minus 2 plus 1 is 1 square 1. J coefficient is 2 plus 2. 2 plus 2, 4 square 16. K coefficient square. Minus 1 minus 2. Oh, this is 9. This is a 9 square. 3 square 9. This is 9 only. 1 plus, right. 25, 26. So, 3 by 2 into 9 into 26. So, what is this? 3 by 2 into 9 6 are 54, 18, 23. Yes. 3 by 2 into root 3 by 2 into, yes, 3 by 2 into root 34. So, this is correct. Now, acute angle between PQ and PR. PQ and PR, this angle. Okay. So, this angle we want. This angle. So, we can find PQ drs and PR drs. Okay. Right. So, PQ drs, right? PQ drs. So, next, so drs of PQ. What is that? Drs of PQ, just I think just we can calculate it. PQ, PQ PR, yeah, PQ PR, right? PQ PR. Yes, PQPR is, you can take this here only. This is what? Minus 1, 1, minus 1. These are the DRs, right? So, PQPR, angle between this, okay. This only you take, minus 1, 1, minus 1. Then PR, DRs, 2, 1, minus 2. So, DRs of PR, that is, okay, this is the DR symbol. So, 2, 1, minus 2. Yes. Now, cos theta you can apply now. A1, B1, C1, A2, B2, C2. Therefore, cos theta is minus 2 plus 1 plus 2 by root of root 3 into this is what? 3. So, cancel. Cos theta is 1 by 3 root 3. So, theta is cos inverse 1 by 3 root 3. I think it is given, right, 2 root 3. So, it is not correct. So, this is not correct, right. So, AC correct. Right. Now, what is this question? Yes. Oh, the functions question, right. Oh, this is what here. F is n to z, G is z to n. G is z to n. So, codomain z here, z, this G circle F exists, F circle G also exists, right. Okay, now we can write f of n. So, f of n is, so if you take 1, right, when order, this is 1 plus 1, 1. So, 1, right. Now, if you take 2, n is even, 2 minus 2, 1, right. So, 1 is 1, 2 is 1, there is many 1, right. Now, next, if you take 3, n is 3, 3 plus 1, 2, and if you take 4, 4 minus 4, 0, right. If you take 5, 5 is odd, 6, 3, and if you take 6, 6 even, 6, 4 minus 6 minus 2, minus 2 by 2 minus 1, okay. So, now if you take 7, this is odd, 8 by 2, 4 and so on, okay, right. So, f of n is, what is that? F of n is this, right. So, n is 1, this, 2, this. So, we want, see, many one function, many one, right. All the values of z is there here. Here minus 1, 0, 1, 2, 3 is coming. Matlab codomain is range. Codomain is range. You know, 0, minus 1, 2, 3, negative, positive, all these are coming, right, for some values. That means f of 1 is many 1 on 2, right. Therefore, f of n is many 1 on 2. Many 1 on 2 function, right. Okay. Now, we will take g of n, right. So, g of n we can write, what is that? G of n also like this only we will write. If you take negative values, we will write first. If you take suppose minus 3 plus 6, you know, minus n is negative, minus plus 6, n is minus 2, 4, minus 1, 2, right. If you take 0, 0 positive, that is 3. If you take 1 means this, 1 means 5, right, 1 is 5, and if you take 2, 7, and so on, right. So, therefore, g of n is what you can take this here, minus 3 minus negative values are there, g of n z to n, z to n. So, therefore, Z to n, but n values, all values are not coming in this codomain. 6, 4, 2, even only coming, some odd coming, right? So, it is what 1, 1 into function, right? G of n is 1, 1 into. So, therefore, right here n, G is what? Z to n. Z to n. N is natural numbers 1, 2, 3 n, right? 1, 2, 3 n. So, you are not getting here 1. So, that is why some elements missed in this. So, codomain is not range. So, therefore, it is what G of n you can take 1, 1 into. Therefore, G of n is 1, 1 and into function. Okay. Now, we will write f of Gn, right, because here G circle f circle G is. So, therefore, we can take f is not 1, 1, but f is on 2. Yes, D correct, right, many 1 on 2. So, it is not 1, 1. So, it is because of many 1 is on 2. So, therefore, D correct, and we will check this. G is 1, 1 and G is on 2. Oh, no, G is 1, 1, but into, because here natural numbers 1, 2, 3. So, we are not getting 1 any case of this. If you take G of n is 1, G of n is 1. What happened? 3 plus 2n, you will get, what is that? Minus 1 is n, right? So, it is there in Z, but here minus n negative for this case. So, therefore, you cannot, codomain is not equal to what? Range. So, therefore, it is not onto, it is into function, right. Now, we will get, we will go for G circle f of this, right, f of Gn we can calculate, f of Gn. So, you put in place of n Gn, right, what happened is, so f of Gn is what? N plus 1, 3 plus 2n plus 1 by 2, 3 plus 2n plus 1 by 2. What is that? N greater than or equal to 0 and n is odd. Now, what is this? This is n plus 2. Now, if you put here this case, 4 plus 2n by 2 is what? N negative, n is even. That means it is also n plus. So, therefore, f of Gn is n plus 2, n belongs to Z. So, it is what? Linear 1, 1, correct? Linear 1, 1. So, now it is what is given? 1, 1 and not on 2, not into. Yes, it is 1, 1 on 2, 1, 1 2, because G of n plus linear. So, therefore, f circle G of n is f circle G of n is 1, 1 and on 2. So, therefore, right, on 2. So, next, now we will find G of f of n. Okay. So, what is G of f of 1? G of f of 1 will calculate, right, G of f of 1. Okay, what is f of 1? F of 1 is here, that is 1. So, G of 1. So, G of 1, 5, correct? G of 1 is 5. What is G of f2? So, f2 is here, f2 is for 1. So, it is also 1. this is a 5. So, it is what? Many one. So, therefore, g of f of n is many one into function. Many one into, it is given onto. So, therefore, and g of f of n is not equal to 1. G of n not equal to 1. Okay. And therefore, g of f of n is many one into function. Many one into many one, right? Many one into function. Okay. So, that is G circle F is what? 1 1. Yeah. G circle F is right 1 1. It's not 1 1. Correct. Not 1 1. G circle is not onto. So, into function. So, therefore, A also correct. So, AD. So, this is a complex number question, easy question, right? Like mains level question only. Just put Z1, Z2, right? You will get the locus. So, what is that? Here, modulus of x plus iy, Z1 is minus 1 minus 2i is equal to 2 times x plus iy minus Z2, 3i. Right. Now, you take this as real part square root of x minus 1 square plus modulus plus imaginary part square y minus 2 whole square. Y minus 2 whole square. This is 2, not z. This is 2. Right. Now, is equal to 2 times this root of x square plus y minus 3 whole square, right? Square both sides, squaring on both sides, right? You will get here x square plus y square minus 2x minus 4y plus 5. 4 times here x square y square minus 6y plus 9. Right? Now, 4x square minus x square is what? 3x square plus 3y square. Right? Minus 24 minus this is plus 2x. Right? X term is what? Here this is a plus 2x plus 2x. Right? Now, y term minus 24 minus becomes plus 4 minus 20y. So, I am transferring LHS to RHS. This is 36 minus 5. So, 31 is equal to 0. So, divide by 3 is a circle. This is a circle. Right. Now, what is the center? Therefore, center minus 1 by 3 and 10 by 3. Radius root of 1 by 9 plus 100 by 9 minus c 31 by 3. So, what is that? Radius r equal to 101 by 9. 93 by 9, okay. So, it is what? 8, r is equal to root of 8 by 3, that is equal to right, 2 root 2 by, into 3, 9. So, 2 root 2 by 3. So, this is a D, correct? A, correct. Right, minus 1 by 3, 10 by 3 center radius. Okay. Okay, now the set of all relations, integer type questions, right? Set of all relations on the set ABCDF such that R is reflexive and symmetric and R contains exactly 10 elements be denoted by S. The number of elements in S is, right? Number of elements in S is. Okay. So, here what is that number of elements in A cross A, that is set R, right? R is on the set this. Okay. If you take A is equal to A, B, C, D, E, F. So, 6 elements, right? So, what is A cross A? A cross A is like A, B, A, C, A, D, A, E, A, F. So, this is a first element, right? So, next BA, BB, BC, BD and BE, BF, right? BF and so on, right? So, these are FA, FB, 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 FC, FD, FD, FE, EFF, right? Right. See, if a relation, this is a F is a set of all elements on R, set is this. So, therefore, A cross A. So, therefore, F is a relation from A to A, right. So, F is from A to A. So, these are all elements in F. Now, if F is symmetric means we should take all diagonal elements, right? Should take all diagonal. This is B, 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 right? So, this is we can take all diagonal elements, right? So, total 36 elements, right? 6 into 6. So, out of 6, 36, 6 is gone, right? Now, remaining how many? 30. But 30 is what? Symmetry A, B, B, A, right? So, remaining what? Remaining 36 minus 6, 30. 30 to this is 15, this is 15. So, but we need to find 2 elements such that R contains exactly 2 elements and R must be what? Reflexive and symmetric. So, obviously A, B, B, A is symmetric, but we want 2 elements we have to select from remaining what? 15. So, that is what? 15 C2. So, therefore, here write if relation is reflexive, we must take diagonal elements. Take diagonal elements. Okay. Now, from remaining 30, right, we need we need 15. From that 15, we have to take 2 pairs. So, because exactly 10 elements should be there. So, therefore, from remaining right 30 pairs, right 30 pairs, 30 minus 15 only, right, 30 minus 15 is equal to 15, right, pairs. We need 2 pairs such that R contains exactly 10 elements, R contains exactly 10 elements, and R is reflection symmetry. See, A, B, B, A. This is symmetry, reflexive, diagonal. So, A, B, B, A, right. So, therefore, exactly 10 elements and R is reflexive and symmetric. So, that means what? From 15 we selected 2 pairs. So, therefore from 15, right, we can select 2 pairs in 15C2 ways. So, what is this? So, 15C2, 15 into 14 by 2, 2 7s 105. So, this is the answer. So, now it is a question given from vectors, right. For any 2 points m and n in the xy plane, mn bar denotes the vector from m to n. O bar denotes the 0 vector. Let PQR be 3 distinct points in xy plane. Let us be the point inside the triangle. Yes. So, this is given. Let E and F be the midpoints of the sides PR, QR, respect then the value of length of line segment EF by this. Okay. So, we will take this figure like this, right. You can take like this triangle P, Q, R will take. This you take 0 bar, say 0 bar, say this is A bar, say this is B bar, say let, okay. So, now S is inside the point, okay. I will take inside some centroid I will take, right. So, yes, I will take centroid. What is that? A bar plus B bar by 3. S is inside, you can take anything, right. Okay. So, you can take circumcenter also, incenter also, but it is easy to find the what centroid. Now, what is that? M and N, this xy, let us M and N, okay. Now, E and F with the midpoints of PR, QR. So, PR, M is this, E and F, E is the midpoint of this and this is the F with the midpoint of this PQ, PR, QR, yes, PR, QR, right. Now, this is the vector, right. Obviously, it is parallel to third and half of the third, right. There is a concept, right. In a triangle, line joining any 2 sides, midpoints of any 2 sides is, right, parallel to third side, half of the third side. So, this is half of this, okay. So, now, here, what is that? ES, right, ES, length of ES, EF by ES, EF by ES. So, this, right, okay. Now, what is that? One more condition is there here. So, SP bar, phi SQ or 0 bar. Okay, first we will simplify this part. So, SP bar plus 5 SQ bar and 6 SR bar is equal to 0 bar. Okay, now it is what? OP bar minus OA bar. OP bar is 0. So, that is 0 minus S, that is minus of A bar minus B bar by, okay, we will write one more step. This is OP bar minus OS bar plus 5 into OQ bar minus OS bar, 6 into OR bar minus OS bar is equal to 0 bar, right? This is what 0 bar, OP bar is 0 bar, minus OS bar is that, right, A bar plus B bar by 3, centroid S. Now, 5 times OQ bar is A bar minus OS bar, that is A bar plus B bar by 3, A bar plus B bar by 3. Now, 6 times OR bar, B bar minus again A bar plus B bar by 3, 0 bar. Okay. So, now we can write this here. Okay. So, what is this? Minus A bar minus B bar by 3 plus 5 times 3A minus 2A bar minus B bar by 3, and here plus 6 times 3 minus 2B bar minus A bar by 3 is equal to 0 bar. This 3 cancel, right? Okay, what is this? Minus A bar minus B bar, 10A bar minus 5B bar plus 12B bar minus 6A bar, 0 bar, right? Okay, so what is A bar? 10 minus 6, 4, 4 minus 1, 3A bar. B bar, 12 minus 5, 7, 7 minus 1, 6 B bar. So, A bar plus 2B bar is 0 bar. Okay. Now, we can write this, right. B bar is minus A bar by 2. Okay. Now, we want length of EF, that is therefore length of EF means mod EF bar by length of ES bar, mod ES bar. What is this? OF bar minus OE bar by OF bar minus OE bar. This is OS bar minus OE bar. Well, or you can take EF bar is half of this. You can take that easy instead of this. Okay. This is what? Mod A bar by 2. Yes. Half of third side. Now, OS bar, mod A bar by 2 by OS bar. OS bar is A bar plus B bar by 3. A bar plus B bar by 3. OE bar. OE bar. It is a midpoint. B bar by 2. B bar by 2. OE bar is B bar by 2. Yes. So, but B bar is minus A bar by 2. You can substitute here. So, mod A bar by 2 minus by modulus of A bar. Okay, so 6 LCM we can take. 6 LCM. So, 2A bar plus 2B bar minus 3B bar, right? So, it goes to what is that? This is but B bar is minus A bar by 2. B bar minus A bar, okay. So, this is mod A bar by 2 into 6 by 2A bar. This is minus B bar. Minus B bar is minus b bar is a bar by 2. Okay, 2b minus 3b, 2b minus b bar is a bar by 2 plus a bar by 2. Okay, and this is what 2 3s are. So 3 mod a bar by, this is what 5 by 2 mod a bar cut, 6 by 5, 12 by 10, 1.20, that is the answer, right, 1.20. No. So here, what is that? Is also integer question, right? Let S be the set of all 7-digit numbers that can be formed using this 0, 1, 2. For example, this, like, repetition is also allowed, is in S, but this is not, because is there 0 is there, 6-digit number. Now, then the number of elements in X, I think, okay, what is this? Let S be the set of all even digit number, 7-digit number formed with this. Okay, I think it is not there in S, such that at least one of the digits 0 and 1 appears exactly twice in X is equal to. Okay, so here there are 3 cases possible, right? Suppose let capital A be the set of numbers, set of 7-digit numbers, 7-digit numbers, 0 is exactly twice, 0 is exactly twice, 0 is exactly twice, 2 times, this is one case. Now 1 exactly twice, B, let B be the set of 7-digit numbers, 1 is exactly twice. Now C, it is nothing but A intersection B, right, exactly 0 and 1 is exactly twice. This is the 3 cases. From this side we will subtract this. Okay, so A, what is that? That is 0 exactly twice, right? Suppose here 1, 2, 3, 4, 5, 6, 7, 7-digit number. So here 0 cannot, right? 0 cannot. That means remaining what? 6, we can select 2, 6C2, right? And this 2 ways, this 2 ways, this 2 ways, right? This 2, like this you can, this 2 ways, this 2 ways. So this is what? 2 to the power of 5. So therefore this is n of A is 6 into 5 by 2 into 32, 2 3s are 15, right? This is what 15. Okay, this is 15, 32 into 15, 30, 480. So this is 480, right? This is 480. Okay. Now B is exactly once, right? Set B. So set B exactly once, that is 1 is in the tens place or 2 in the tens place, right? So this is what? 1 is in 10 power 6 place. 1 is in 10 power 6 place, right? That is last, what leftmost place, or addition 2 is in 10 2 is in 10 power 6 place. Okay, right. 1 is exactly in twice. So that is what this is 6C1 into 5 places 2 power 5, or this is what 6C2 2 to the power of 4. So therefore n of b, right, 6C1 is 6 into 32 plus 6C2 15, 15 into 16. So n of b is equal to, this is a 192 plus 240. Oh, so 15, 6 and 90, 240. So that is what 240 into 192, that is 2, 3, 4, 432. 432. Okay. Now C, that is a, what is that? Exactly 0 exactly twice, 1 exactly twice. So it is like this, right? 0, 0, 1, 1, 2, 2, like this. But here it cannot be 0, no? So this is what you can write. This is 7 factorial by 3 factorial, 2 factorial, 2 factorial, minus, right, 0 without 0 here. That is what 6 factorial by 3 factorial, 2 factorial. So this is what n of C. What is that? This is 7 factorial or 6 factorial. 6 factorial is 720. So 720 into 6. Sorry, 7. 6 factorial is 720, right? 3 factorial 6, 24 minus 720 by 6 to the 12. 24 3s are 12 60s. So 210 minus 60, that is 150. Now therefore required number of digits, required number of 7-digit numbers, use principle of inclusion exclusion. 7-digit numbers equal to n of a plus n of b minus n of a intersection b. This is a intersection b, this n of a intersection c. C is a intersection b. This is how much? So we can take n of a, how much? 480. 480. N of b is 432. 150. How much? 480, 432, 2, 1, 9, then 150 subtract 2, 6, 7, 762. 762. Okay. So this is a limit and Leibniz theorem question, right? So this is alpha plus beta we want, right? So that is limit extends to 0. We can write this alpha by 2, 0 to x, 0 to x by 1 minus t square dt, and plus beta x cos x whole by x cube, we will write like this, is equal to. So it is 0 by 0 form. X tends 0, 0 to 0, 0, b at beta x 0, 0. So 0 by 0 form, right? LHS is a 0 by 0 form. So we will use L'Hospital rule, right? In numerator, Leibniz theorem. So what is this? Limit extends to 0 alpha by 2, right, 1 by 1 minus x square plus here beta cos x, right, this derivative minus beta x sin x whole by, what is that, 3x square is equal to 2, right. So, as x tends to 0, what is that, alpha by 2 plus beta 0, right. So, as x tends to 0, that is numerator is alpha by 2 plus beta, this 0. So, cross multiply 0. So, alpha plus 2 beta 0. For this, again it is 0 by 0 form. If you put beta value or alpha value here, right, it is 0 by 0. Okay. So, now for that we will apply series. So, alpha by 2, this is 1 minus x square power minus 1 plus beta cos x minus beta x sin x whole by 3x square is equal to 2, right. Under this condition it is now 0 by 0. Now we will do the series. It is 1 minus x power minus 1, right, infinite binomial expansion. So, you can take here this side, you can take what is that, limit x tends to 0 alpha by 2 1 plus x square plus x power 4 x power 6, like this expansion, infinite terms, and cos x expansion also you can write. So, beta into, right, 1 minus x square by 2 factorial x cube by 3 factorial minus, x power 4 by 4 factorial 24, even, right, alternate signs, infinite terms, and beta x into sin x minus beta x minus beta x sin x, because this derivative beta cos x cos x minus sin, right, correct. So, minus beta x sin x odd x minus x cube by 3 factorial 6 x power 5 by 5 factorial 120 minus plus on infinite terms whole by 3x square is equal to 2. Yes, if this is a, right, if this is a finite value, right, this is finite value, then numerator degree, denominator degree must be same, right. See, is a finite value 2. So, numerator degree, denominator same. Here 2, no, denominator degree 2. So, numerator degree minimum 2, right, before all 0, constant term 0 and x coefficient 0 and x square coefficient is 2. So, therefore, coefficient of x power 0 implies constant alpha by 2, right, plus beta remaining not there, beta 0. It is the same as that equation. So, alpha is equal to minus 2 beta, equation 1. Now, coefficient of x 0, coefficient of x also 0. What is the coefficient of x? It is not there, okay, it is not there everywhere, no. Now, coefficient of x square is equal, coefficient of x square is equal to 2, yeah, this, right. Coefficient of x square is what? Alpha by 2, here minus beta by 2, here minus beta by 3 is equal to 6, okay, by 3 is equal to, so where here you can take alpha is minus 2 beta, you can put here minus 2 beta. So, minus beta minus 3 beta by 2 is equal to 6. So, minus 5 beta by 2 is equal, this is equal to 12. So, beta is minus 12 by 5. Alpha will be 24 by 5. What is asking? Alpha plus beta is asking. So, therefore, alpha plus beta is, alpha is 24 by 5, beta is minus 12 by 5. So, it is equal to 12 by 5, 5 2s are and 25 4s are. So, 2.40. 2.40 is alpha plus beta. Right. Now, one more integer question. Right. So, here, see here one standard relation function given. See, whenever f of x plus y equal to f of x into f of y, function is of the type what? Fx is k power x, right. So, therefore, fx plus y is equal to fx into fy. This implies fx is a k power x, k greater than 0. Yes, this is a standard from functions, right. Okay. Now, right, now we will apply one by one condition, this, and these are in AP and this condition is given. So, what is this? F of A31, right, f of A31 is equal to 64 into f of A25, right. F of x, you know, k power x, f of a power 30, f of A31 is k power A31, 64 into that is what, k power A25, correct. But A1, A2, A3, AP now. So, that is, we can use an, a plus n minus 1 into the formula. So, k power a plus or a1 plus, first term is a1 or a, I am taking. This first term you can take a say, right. So, therefore, a plus 30d is equal to 64 times k power a plus 24d. So, here k power a cancel both sides, right. So, k power 30 minus 24, 6d is equal to 64. So, k power d whole power 6 is 2 power 6. Therefore, k power d 2 power 6, equation 1, right. K power d is 2 power 6. Now, one more condition is given. This condition I apply, right. So, that is this condition. Then we can put in this, that two values. What is that? Here, sigma I is equal to 1 to 50 f of ai is equal to 3 times 2 power 25 plus 1, right. Now, f of a1 plus f of a2, f of a3 plus so on, f of a50 is 3 times 2 power 25 plus 1, right. Now, again this is what here k power a1. So, that is k power a1 first term, that is a we can write, right, k power a, right, a1 is a, right. Now, plus a2 k power a2 a plus d plus k power a plus 2d like this and so on. K power a plus 49d is equal to 3 into 2 power 25 plus 1, right? Now it is again GP. Okay, how many terms? 50 terms. What is the first term? K power a. First term is k power a, and common ratio k power d. K power d whole power 50 minus 1 by k power d minus 1 is equal to 3 into 2 power 25 plus 1. Okay, right. But k power d how much? 2 power, oh sorry, k power d is 6 only. K power d is a 6 only, not 2 power 6, right? So therefore, because powers equal, base equal, right? So substitute k power t value. So k power a, this is 2 power 50 minus 1 by 2 minus 1 is equal to 3 into 2 power 25 plus 1, right? Okay, now here one factor cancel. So what is that? K power a is equal to 3 by one factor cancel. This is 2 power 25 plus 1 cancel minus 1. This is k power a value. Now we want this value. Substitute these two. What is that? In that. Okay, these two. So therefore, right, sigma, right, we want this value, right. So what is that? Sigma I is equal to 6 to 30 f of ai. Yes, this value we want, right? So what is this? F of a6, right? F of a6 plus f of a7 plus f of a8 and so on, plus so on, f of a30, f of a30, f of a30, okay. This is what, again, this we can write k power a plus 5d. So how many terms these are? 6 to 30, 1 to 30, 30 terms, minus 5, 25 terms. So these are 25 terms, okay, 1 to 30, 30 terms. Before 5 terms, 1 to 5 subtract, so 25 terms. So a k plus 6, this is 6 5d, a plus 6d plus so on, right? K power a plus 29d, okay. Yes. So this is what GP again, k power a plus 5d first term. What is the common ratio? K power d minus 1 by k power d minus 1, power 25, na? 25 terms, okay, right. K power d is 2, okay. This is what? K power a into k power d whole power 5 into k power d 2 power 25 minus 1 by 2 minus 1, right? But what is k power a? This 3 by 2 power 25 minus 1 into 2 power 5 into 2 power 25 minus 1 by 1. This will cancel. 3 into 32, 96 is the answer, right? 96 is the answer. Now, the differential equation question, right? So, y1, y2, y3, these are the functions satisfying these differential equations, and respectively then limit extends to this, right? Okay. So, from this differential equation, what we can write, dy1 by y1 is equal to, what is that, sin square x dx, sin square x dx, variable separables I applied here, this, from this equation, right? Okay. Now, similarly, dy2 by y2, this implies dy2 by y2 is cos square x into dx. Now, this is implies dy3 by y3 is 2 minus x cube by x cube and dx. Okay. Equation 1, 2, 3. Now, we will add 1, 2, 3, right? So, 1 plus 2 plus 3 will add. What is this? dy1 by y1, dy2 by y2, dy3 by y3, okay? Sin square plus cos square 1, and here 2 by x cube minus x cube by x cube 1 dx, right? Okay, 1 cancel. Now, what is that? We will integrate both sides. Integrate. Integrate. So, what is that? Integral dy1 by y1, dy2 by y2, dy3 by y3 of, this is what? Integral 2 by x cube dx. Okay. This is what? Log y1, log y2, log y3. So, therefore, log of y1 into y2, y3. Because log m plus log m plus log n, there is log m plus log n plus log n, log m and p, that is equal to minus 1 by x square plus c. 2 cancel. Okay. Right. So, now y1 of x into y2 of x, y2 of x, right, y2 of x into y3 of x, y3 of x, right, y3 of x is equal to e power minus 1 by x square, this is some k, e power c k, right. So, this is 4. Put x is 1 in this, because y1 of 1 and all this given. So, put x equal to 1, right, that is in 4. This is the fourth equation. This is the fourth equation. This is the fourth, right. So, x is 1. So, y1 of 1 into y2 of 1 into y3 of 1 k times e power minus 1, e power minus 1, because x is 1. But y1 of 1 is given 5. Substitute here. So, 5 into 1 by 3 y3, 3 by 5e is equal to k by e, e cut, 3 cut, 5 cut. Therefore, k is 1. Put here in 4. Put in 4. Put in 4. Therefore, y1 of x into y2 of x into y3 of x e to the power of minus 1 by x cube. Now, we want limit of this, okay. So, therefore, limit x tends to 0, y1 of x into y2 of x into y3 of x whole by e power 3x into sin x. Yes, substitute this value, right, e power minus 1 by x cube. So, limit x tends to 0, okay, plus 2x also there here, plus 2x in the question, right. This is what e power minus 1 by x square only, cube nahi, square, square, right. So, minus 1 by x square plus 2x whole by e power 3x sin x, right. This is what 0 by 0 form, right. So, you can use L'Hospital rule or you can apply this x common, right, e power minus 1 by x square by x plus 2 by e power 3x and sin x by x, okay, the x divide here. So, this is what 1, this is 1, this is what 0, right, x tends to what 0 plus, yes, x tends to 0 plus, e power minus infinity tends to a larger value, finite value. So, 0 plus something 0. So, therefore, 0 plus 2, that is what 2, that is the answer. Now, it is a matching question, right. See, what is that question is, consider the following this frequency, right, value frequency given and sum of the, right, frequency is 19, median 6, right. Alpha denotes the mean variation about mean, beta is the mean deviation about median, right. So, this is variance, these are questions, okay, right. Now, we will write the this table, right, what increasing order, right, all calculation part, right. So, this will take given values x, right. This is a value, this is what xi you can take, then frequency, right, f, frequency, right, this is f, right. So, or fi you can take, this is a cumulative frequency, we can write cumulative frequency, and this is what xi into fi, right. So, what is that first 4 frequency 5, right, 4 frequency 5 and 6 frequency 1, 5 frequency 5 f1. So, f1 5 6 1 6 1 6 after 6 8 f2 9 2 11 3, then 12 1, 12 1. Okay. Now cumulative frequency we will write, cumulative frequency we will write. So this is what 5 plus F1 this is 6 plus F1, this is 6 plus F1 plus F2, this is 8 plus F1 plus F2, and 11 plus F1 plus F2, then 12 plus F1 plus F2. Yes, okay. But this sum is given how much? 19, sum of the frequencies. So therefore, this is 12 plus F1 plus F2 is 19 is, we will get F1 plus F2 is 7. So therefore, 12 plus F1 plus F2 is 19. Therefore, F1 plus F2 is what? 7. Equation 1, right? Now, given that median 6, median is 6. What is that median? So, median is here how many terms? 19 terms, odd. So, n plus 1 by 2th term. Okay. So, median, median is 6. But, so what is the median? N is what? 19. So, n plus 1 by 2th term is median. N plus 1 by 2th term is 19 plus 1 by 2. 10th term is median. 10th term. What is the 10th term here? Right. So, that is F1 plus F2 is 6. Right. So, that is here 5 plus 4 9. This is okay. F1 is F1 plus F2 7, 10th term. So, 6 plus F1 is 10, median 6. Therefore, 6 plus F1. Therefore, 6 plus F1. So, here 5 this, right, 9. So, 10th term, 6 plus F1 is, what is that? 10. So, F1 is 4. F1 is 4. So, 5 plus 4, 9 plus 1, 10. This is a median, 6 plus F1, 10th term. Okay. So, F1 is 4, F2 is 3, F2 is 3, F2 is 3. Okay, F2 3. So, is asking what? 7F1 plus 9F2. 7F1, that is what? P. P 7F1 plus 9F2. Right? 7F1, 7 into 4, 28. 9F2, 27. This is what? 55. So, 55 is their S. So, PS, this is S. So, PS, right? PS, oh, S nahi, 5, sorry. This is 5, not S, right? This is what? 5. This is 5. So, P5, 1, 2, A, B, C is there. Okay. Right. Now, we will check other cases. Right. Now, you know F1, F2 we can find this. What is that? Sigma xi Fi. Right. This is okay. So, what is that? F1 is 4. This is 4. This is F2 is 3. Right. Now we can find the sigma fi xi, because we have to find the mean. What is that? This is a 4, this in 4 5 is a 20 and 20, this also 6, 24, 18 and 33 and 12. Okay. What is this? 40 plus 30, 70, 70 plus these two, 30, 100, 133. So 133 this is sigma fi xi. Okay. We can find the mean, right? We can find the mean. What is that mean? Okay. Now we can find the mean, right? Right. So what is that mean? Mean formula. So mean x bar equal to sigma fi xi by sigma fi. So 133 by fi. Sigma fi is what? 19. 19. How many times it go? 7. 7. Yes. So 7. Right? Mean is 7. Okay. Now he is asking what? He is asking, okay, what is that? Median of the frequency 6. Okay. For given frequency, so alpha denote the mean deviation about the mean. Mean deviation about the mean we can find. Mean deviation about the mean. Okay. Right. Mean deviation about the mean. Mean deviation about the mean. About the mean. What is that? Formula sigma fi into xi minus x bar by sigma fi. This is the formula. Right? Sigma fi means this. Right? So 5 into, okay, 5 into xi minus x bar. Xi minus x bar is this. 7 minus 4, 3. X bar is 7, 3 plus 4 into 7 minus 5, 2. 4 into 1 into 7 minus 6, 1 plus 3 into 1 modulus, no? 3 into 7 minus 8 plus 2 into 2 plus 3 into 4, right? 1 into 5 by 19. By 19, yes. So this is what? Alpha. This is given alpha. है ना? So, right, alpha denotes the mean deviation about the mean. Okay, right. Now we can find this 15 plus 8 plus 1 plus 7 plus 4 plus 12 plus 5, right? Right, whole by 19. So 19 alpha is equal to 23, 24, 31, 31, 35, 35, 40, 40, 52. 52 there. 19 alpha, 52. Yes, 52 not there. 52 not there. We can see 23, 24, 24 plus 7, 31, 35, 40, 52. Correct only, right? 19 alpha is, so sigma xi in fi into xi, this f, this is 5, 5 into 7 minus 4, 2, 7 minus 4, 3, 4 into 7 minus 5, 2, 1 into 7 is 1, 3 into 7 minus 1, yes, 3 into here, this is 3 into, right, not 7, this is 3 into 1, 3 into 1, 3 into 1, 2 into 2, 3 into 7 minus 4, 4, 1 into 7 minus 5, 5. Now what is this? So it is 3, it is 3, right. Now it is what? 23, 24, 27, 27, 31, 31, 36, 36, 48, 48, 48, yes, 48 is there, 3, correct. So 48. So therefore, Q is Q is, what is that Q? Q is 3, Q3, right? Therefore, Q is 3, right? P5 Q3, P5 Q3, P5 Q3, yes, A. Oh, C also there, C also there, Q3. Now we will find R also, okay? What is that R? 19 beta. Beta is what? Beta is mean deviation about the median. Okay, median is 6, no? Okay, we can find, right, mean deviation about the median, beta. Mean deviation, next, mean deviation about the median, about the median. So median given, no? 6, capital M, 6 given, right? Now what is that formula? This is given beta. Therefore beta equal to, right, sigma Fi, same formula but small change, capital M here, by sigma Fi, right. Now that is what? Same, 5 into 6 minus 4, 2. So beta is, we'll write here, right. So beta is, okay, beta is equal to 5 into 6 minus 4, 2, 5 into 2, right, plus 4 into 1, 4 into 1, plus 1 into 0, 6 minus 6, 0, plus 3 into 2, 3 into 2, plus 2 into 3, 2 into 3, right, 2 into 3, 2 into 3, 2 into 3, 3 into 5, 3 into 5, 1 into 6 by 19. So 19 beta is equal to, right, 10, 14, 14, 20, 26, 26 plus 15, 15, 26, 15, that is 41, 41, 16, 57, 19 beta is 57, 19 beta is 57, oh 47 is there, 57, okay, What is that? Mean deviation this, okay. So, what is that? You take this calculation once again. This is what 10, 5 into 6 minus 4, 2, 4 into 1, 1 into 0, 3 into 2, 2 into 3, 3 into 5, 1 into 6. Oh, this is 1 into 6, right? Not 16. What is it now? This is 10, 4, 0, 6, 6, 15, 6, right? So 14, 20, 26, 26, 6, 32, yes, 47, right? So 19 beta is 47. 47. So 47 is which one? 19 beta. 19 beta is 47, 2. R2. R2. Right? R2. R is 2. Yes. Right? P5 Q3 R2. P5 Q3 R2. Yes. R2. Yes. A. P5 Q3 R2. O. C also there. We have to decide S. Yes, we have to decide S. Okay. S we have to calculate. S. What is that? S. 19 sigma square. That is variance. Variance. Denote the variance. Okay. We will do that. Variance. Okay. So, variance. Right? Variance. What is the formula? Variance sigma square is sigma Fi into xi square by sigma Fi minus x bar square, mean bar square. Okay. So Fi, right? Fi, this is Fi into sigma xi square, 5 into 16, right? 5 into 16, 5 into 16, 4 into 25, 4 into 25, 1 into 36, 1 into 36, 3 into 64, 3 into 64, 2 into 81, 2 into 81, 3 into 121, 3 into 121. Now 3 into 121, 1 into 144, 1 into 144 whole by what is that? 19 minus mean 7, 49. I calculated, I will tell, I will write. So this is 1077 by 19 minus 49. So 19 sigma square is equal to this is 146 by 19. So therefore 146 is the answer. So 146, right? 19 is 146, 1. That means C correct. C correct, right? So S, what is that? So that is S is 1. S is 1. So S is 1. Therefore S is 1. Therefore option C correct. Option C. Right. Lengthy question. Calculation. Right. Now this question. What is that? Minimum value of n for which the function affects this. This is the step x. Right. Greatest integer function. Greatest integer function. Okay. You take this is gx. Right. P. Let gx equal to what is that? 10x cube minus 45x square plus 60x plus 35, right? So now g dash x will find out 30x square plus minus 90x plus 60 equal 0. This implies what is that? X square minus 3x plus 2. So x equal 1 comma 2. Now g double dash x. Look at find maximum. 60x minus 90. Right? So g double dash 1 is equal to minus 30 negative. So therefore gx attains maximum. Gx attains maximum. So therefore maximum of gx. Maximum of gx is what is that? G of 1. G of 1. G of 1 is what? 10, 45, 60, 35. Okay. So 45 cancels 60. G of 1 is 60. So maximum is 60. Now obviously at 2, what is that? At x is 2, 120 positive. So minimum. So therefore minimum of gx, not g of 2. G of 2, that is 80 and 4, 1 minus 180, 4 into 45 and 120, 60 into 2 plus 35. So this is what? Minus 100. Minus 100 plus 120, 35. So 55. So therefore 55 is less than gx less than 60. Okay. Now function is continuous, right, in this interval 1 to 2. So therefore, so f of x is what? This 55 less than or equal gx less than or equal 60 by n, right, is continuous in the whole interval 1 to 2, right. Can take here. Right. So if fx is continuous in the whole interval 1 to 2, whole interval 1 to 2, right. So it must be what? Constant. It must be constant. Same value. So value remains same. Value must be remains same. Remains same. So for n is equal to 55, 60, no? So that is you take n is 9. I know here n is 9, right. For n is 9, what happened? For n is 9, what is f1? So n is 9, f1 is okay, f1. This is what? N is 9, f1 is 10, 45 can 60 by 9. That is what? 6. And 9 6 are So F2 is also will get same 6. That means remains same. So therefore n is 9. For other values varying. That's why. So n is 9. Least value is 9. That is 2. This is what? 2. This is P is 2. Right? P is 2. Therefore P2. P2. Okay. Now here minimum value of n for which g of x is increasing for all x belongs to R. Right? Right. So we can take, right, now g of x, q question, g of x is right. So g dash x must be greater than 0. G dash x greater than 0 for increasing function, correct? For all x. So right, g dash x is what? 2n square minus 13n minus 15 3x square plus 3 greater than 0. So this is always positive, right? This must be positive. Therefore 2n square minus 13n minus 15 greater than 0. So 30, 15 2s are 2n square minus 15n plus 2n minus 15 greater than 0. So n common, 2n minus 15 plus 1 into 2n minus 15 greater than 0. So n plus 1 into n minus 2n minus 15 greater than 0. So n belongs to minus infinity minus 1 union 15 by 2 to infinity. But integers in the options, right? So least integer is what? 7.8. So least n 8 from least 2. Least 2. So what is that? Q1. Q1, right? Therefore Q1. See, P2 Q1. P2 Q1. P2 Q1. Yes, B. No other. No need of RS. Right? P2 Q1. Right. Next. Okay. Now this vectors question. Right? Oh, this is okay. What is that? So U W bar given, U cross V, W bar, V cross W, U, let alpha, beta, gamma, T be real numbers, then this, okay. So here mod of W bar how much? Root 6, and mod of U bar how much? That is root of alpha square plus beta square plus gamma square, right? Now what is given? U cross V, W bar given, U cross V bar, W bar given, equation 1, and V bar cross W bar, V bar cross W bar is what? U bar 2, okay. Now here take dot with U, right? Take dot with U bar. So this will be 0. U dot U cross with 0. So 0 is equal to U bar dot W bar. Similarly, take dot with U. Dot with U, no? U over. Dot with V. Dot with V. Right? So W bar dot V bar also 0. Here take U dot with V. Dot with V. Dot with V bar. That is 0 U dot V. That means U bar, V bars, W bar mutually perpendicular. Therefore, u bar, v bar, w bar are mutually perpendicular vectors, right? Take dot with u, dot with v. So, we got this dot with v, u dot v 0. So, they are mutually perpendicular. Okay, right. Now, substitute 2 in 1. Put 2 in 1. So, put 2 in 1. What you will get? U, this substitute here, that u here. So, v bar cross w bar cross v bar is equal to w bar, this first equation. Now, you apply long dot near vector. So, v bar dot square into w bar minus v bar dot w into v bar is equal to w bar. But v bar dot w 0, right? So, therefore, transfer this v bar this side, v bar square minus 1 w bar minus 0 bar here is equal to 0 bar. So, therefore, v bar square minus 1 w bar is 0, but w bar is not 0, right? So, this 0. So, therefore, v bar square is 1. So, mod v bar square is 1. So, what is that? Mod v bar square 1, 2. So, P2. So, P2. Okay. P2, all A, B, C is there. Okay. Now, we will go for this, right? Okay. So, mod of this, okay. Now, we can take, right? Now, here, if you take modulus both sides to 1, okay. So, 1 implies you take mod u bar cross v bar is equal to mod w bar. This is mod u bar, mod v bar 1, mod w bar. But mod u bar how much? Mod u bar is, this is u bar, not v bar, mod u bar. This is mod w bar is 6. So, this is 1. So, therefore, this is root of alpha square, beta square, gamma square into 1 is equal to root 6. Therefore, alpha square, beta square, gamma square is root 6, right? Equation number 3, right? Now, we have this one more relation, right? Now, u dot w 0, okay, that will take, and these are simultaneous equations given. So, you eliminate alpha, beta, gamma from these equations, right? So, eliminate alpha, beta, gamma from given equations, from given 3 equations, from given, right? So, what are that equations? This, from this, these are the homogeneous equations in what? Alpha, beta, gamma, right? 3 given equations in terms of alpha, beta, gamma, So, therefore, determinant minus t 1 1, 1 minus t 1, 1 1 minus t 0, okay. So, if you expand this and simplify, you will get t values. So, minus t into t square minus 1, minus 1 into minus t minus 1, and plus 1 into 1 plus t is equal to 0, right? 1 plus t common, 1 plus t common. So, 1 plus t common in the bracket, minus t into t minus 1, this is plus 1 plus 1 0. So, 1 plus t and minus t square minus plus t plus 2. So, 1 plus t and t square minus t minus 2. So, 1 plus t into this is t minus 2, t plus 1. So, obviously, t is equal to minus 1 comma 2. Okay. So, t minus 1 to alpha plus beta plus gamma 0, right? T minus 1. So, t minus 1 if t is minus 1, alpha plus beta plus gamma 0, and u dot w 0, no? U dot w 0. So, u dot w is alpha plus beta minus 2 gamma 0, and u bar w 0 implies alpha plus beta minus 2 gamma 0. So, subtract gamma 0, gamma square 0, and alpha is minus beta, right? Now, substitute in alpha square, beta square, gamma square is 6, this value. So, therefore, put in 3. What is that? Alpha square, beta square is 2 alpha square, 0 is equal to 6. Alpha square is 6. Alpha is root 3 or minus root 3. But here in the problem only root 3 is there, then don't take this. Okay. Alpha root 3, gamma square is how much? 0. Gamma square 0. So, 1. So, Q 1, right? Alpha root 3, right? Q root 3, gamma square 0. Therefore, Q 1, right? Q 1. So, what you have? This is 1, P2, Q1, P2, Q1. Oh, C also there, P2, Q1. Okay, P2, Q1. Okay, we are going to go for another. Alpha is root 3, beta plus gamma whole square. You will see. Alpha. So, R point, right? Or, what is that? Alpha root 3, beta plus gamma whole square. Okay, beta is what? Minus root 3. Alpha equal minus beta. So, that is what? Beta is minus root 3, gamma 0, 3. So, R is 3, 4. R is 4, right? R is 4. R is 4. R is 4 also same. We go for S. We will do S, right? Okay. Oh, what is that question? Right. So, alpha root 2. Okay, alpha root 2 means here t minus 1, no? T2 you can take. The 2 values are there. T is 2, right? T is 2. T2, so what happened? These all equations, alpha, yes, T2, okay, right, yes, T2 implies minus 2 alpha plus beta plus gamma 0, and alpha minus 2 beta plus gamma 0, and alpha plus beta minus 2 gamma 0, right? Capital 1, capital 2, capital 3 will take, right? Okay, we subtract 1, 2, 2 minus 1, that implies 3 alpha minus 3 beta 0. So, alpha equal to beta. Next, you subtract 3, 2. Roman 3 minus Roman 2. What you will get? 3 beta minus 3 gamma 0. That implies beta equal gamma. That means alpha equal beta equal gamma. Alpha equal beta equal to gamma. So, put in 3, right? Put in 3. So, put alpha equal beta equal gamma in 3. You will get what? 3 alpha square is 6, alpha square is 2, alpha is root 2 minus root 2, but in the options root 2 is not there. So, alpha root 2, right, alpha root 2 t plus 3, alpha root 2 t is 2, no? Yes. So, therefore, alpha root 2 t plus 3, that is 2 plus 3, 5, right, 5, that is what, that is root 2 t plus 3 is 5, yes 5, yes 5, okay, P2 Q1 R4 S5, S5 is A, you know, P2, right, P2, this is what given, this is 5, S5, correct, S5, S5, we can write this, right, S5, S is 5, so what is that, P2, right, P2, P2 Q1, P2 Q1 R4 S5. So, A option correct, A option, right, A option, right, A option, right, okay, thank you.